graph of a differentiable function, we figure out which of the following is true.
Okay, so it looks like we're using f of -2 on every one of them, and f of 3 on every one of them, and what else? F of 0. So let's kind of go in numerical order then. So we have f prime of -2, and then we have f prime of 0, and then f prime of 3. And what I gave you on the graph is the function, so f prime is a slope. So at 2, my slope is positive or negative? Positive. Specifically, you don't really need to know, okay? And then at 0, we have a saddle point. It is at 0. And then at 3, positive or negative? Negative. So if I compare positive, 0, and negative, our inequality must be what? D it is. And if you want to physically write out, f of 3 is negative, f of 0 is 0, and then f prime of -2 is positive, you'll notice negative number is always less than, and 0 is always less than positive. So let's go on to number 77. So 77, you'll need card number 6 on the back, and I want you guys to write the theorem on the top. You don't have to, but I think it's helpful when you're studying for it. So integral from a to b of f of x is equal to, silly me. I meant dx. Oh. Oh no. I think I fixed it. So that should be, instead of equal to dx, is equal to the big F of b minus another big F of a. So Red, go ahead and read the question for me.
Let h of x be an interderivative of x cubed plus mx over x squared plus 2. If h of 5 is equal to pi, then what is h of 2?
So since the formula had little f and big F, and this one using h, let's write it in here. If h is the antiderivative, then this one must be the little h. And let's translate big H and little h into this formula. So we have integral from 2 to 5, h of x dx is equal to h of 5, big H of 5, minus big H of 2. And then our goal is to make h of 2 by itself. To make this by itself, I'm going to move this guy step to the left, okay? Because I want that to be positive. And move the integral to the right, meaning we have big H of 2 is equal to negative of the integral, that I'm not going to read all of. And then we have plus H of 5. And let's see about plugging it in. All of this is going to be this integral. So let's write in here, we have negative of the integral, 2 to 5, and it's calculated portion, which is nice. X cubed plus sine of x, all over x squared, plus 2, of course, dx. Plus, do we know what h of 5 is? It is pi. Okay, let's kind of practice our keystrokes on the calculator. How do I find the integral? Math 9, but before math 9, I'm going to go ahead and put in negative. Math 9, and we're going from 2 to 5 of the function. It's going to take a while. And what should your mode always be in for, just in calculus in general? Always in radian mode. If you mess up on this because you put it on degree mode, it's going to be a sad day. Just going to press enter, and then I'll add the pi after. And then plus pi. And that value is in where? B. Boom. Okay, 78, Alex, let's rate. Oh, you're working on something else?
Yeah, sorry.
That's okay. Jocelyn, will you read number 78, please?
The continuous function f is positive and has a domain of x is greater than 0. If the asymptotes of the graph of f are x equals 0 and y equals 2, which of the following statements must be true?
So let's worry about the asymptotes. So we have x equals 0. I'm going to graph it right here. Oh, there you go. And let's also label, just to be specific. If you're in a time crunch, you don't need a label. And then we have horizontal asymptote at where? 2. So here's my horizontal asymptote. Again, label if you have time. I have lots of time. And it says we're looking at, which of the following statement must be true? So we're looking at everything on the right, okay? Everything on the right. So let's see, the function is positive, so y values are positive, and our domain is positive. So am I going to graph my function on the top right or the bottom right? Top right, because it says f is positive. It's always positive, and domain is also positive. It's got to be this right here. And the only one that satisfies that, it's got to be letter what? C it is. The limit as x approaches 0 is going to infinity, which is this right here. And limit as x approaches the infinity is getting to the horizontal asymptote. Okay, so let's go on to number 79. On the back. Okay, 79 probably scared you a little bit. Should not. Absolutely not. It's all about the units. So let's see. Karis, will you read number 79, please?
A file is downloaded to a computer at a rate modeled by the differentiable function f of t, where t is the time of seconds since the start of the download, and f of t is measured in megabytes per second. Which of the following is the best interpretation of f prime of 5 equals 2?
There's two things that are very important here. Underline what f of t stands for in terms of the units. Also, just underline f prime of 5. And let's kind of evaluate what that says. If f of t is representing megabits per second, and if I derive that, we get per second, meaning we have f prime of t is going to be this exact same thing with extra per second. Per second, and derivative is the slope, and slope is per anything again. And if you look at your answer choices, there should only be one spot that says megabits per second. Where is it? B. Done. Don't even read anything else. Otherwise, you're just going to freak out. And then our last one, number 80. Marissa, let's read.
The function f has first derivative given by
The function, you could say.
okay, the function equals x to the fourth minus 6x squared minus 8x minus 3. On what intervals is the graph of f concave up?
So I want concave up, which looks like this. And we're comparing that to our f prime. So let's look at our graph. It is, the graph is concave up when f prime is doing what? Increasing. And we're doing a calculator portion, okay? So we're looking for when it's increasing. So let's write when f prime is increasing. So let's go ahead and graph this. So we have x to the power of 4, and then minus 6x squared, minus 8x, minus 3. And by default, go to zoom 6. Again, you can choose to graph this on your paper if you have time. If you don't, just stick it on, stay on the calculator. So I need to see where its minimum is. So go to our window. What minimum number do you think is good enough? Because negative 10 is too small. Someone give me a number. Negative 50. Let's do that. That was a good number. So we know when it's increasing over here, right? So let's see what the minimum value is. Second calc, minimum is my option number 3. And it's going to say, go ahead and select anywhere on the left of that tip and anywhere on the right of the minimum. And it's going to say, can I calculate between those two bounds? And just say yes. And it's going to say the value is 1.999, which means I can round it to what number? 2. So it's starting at 2 and forever going to the right. So it must be 2 to infinity. Boom.